Alright, okay, I'm back. Sorry about that, what happened earlier. I kind of lost a bit of my cool there, and I needed to take a break, but I didn't want to charge you for, while me being on and having you connected to the lesson. It doesn't really make sense for me to have you on here while I'm trying to take a break. It's wasting your time and my time. What there's a key there's a few key things that I was having issues with when I was doing the questions earlier. We left at question 27, ethane thiol, which is which they give us heat of vaporization and a temperature. They ask us to find the entropy of vaporization for the substance, right? Well, the entropy we do use delta G, which is equal to delta H minus T delta S, right? Delta G, in the case of state changes, which is vaporization, melting, and boiling, is 0. That's why they don't give us an extra unit, right? So our rearrangement from here is we want to find delta S. So delta H, which would be negative when we move it over here, but we have a negative sign coming with the T, divided by temperature, will tell us, well, it's not negative temperature because there's already a negative, the negative signs will cancel out as we divide. Delta H over T will tell us our delta S of vaporization. So our delta H over here, which I'm writing over here, is 27, right? 27.5 kilojoules, which, because delta G is in joules, I'm going to convert this right now into joules. So this is 27.5 kilojoules over the temperature, and it's 35 degrees. It's 35 plus 273, which gives us 308. 308. So our delta S is equal to this, divided by 308. Our delta S is equal to 89.28. And do you know the units for entropy? They're like joules over K mole. Something like that. And at least in the case of entropy of fusion. So this is 25, right? That is question 25. Question 27 asks a very similar question. It asks us to find, let's go to question 27. It asks us to find, will ammonia spontaneously melt at 200 degrees Celsius? It would definitely spontaneously melt at 200 degrees Celsius. But 200 degrees Kelvin, yes, it does. We determined that it does. But what else they asked for was the approximate melting point of ammonia. Well, they give us an enthalpy of fusion and an entropy of fusion. So we can take our delta H and place it above our delta S, factor out the negative sign, to find our T in Kelvin. Delta H in our case is delta H was 5,650. Yep, it's hard. It's really hard to draw without your touchscreen. 5,650 over our entropy, which is 28.9. 28.9. Spring spam. Let's get this done real quick. 0 divided by 28.9. That gives us a temperature of 195. And you may be like, 195? That's a crazy high melting point. Well, it's in Kelvin, so this is like negative. This is like negative some. This is like negative 100 something. Actually, negative 100 something. It's like negative 80 something degrees Celsius. So it's quite chilly, actually. It's almost it's getting pretty close to cryogenic, actually. Degrees Kelvin. And this is question 27. Now, new board. Let's go to these questions. These questions ask us, predict the sign of delta S for each of the following changes. Well, delta S is disorder. You told me that, and I said that. We both know it. It's disorder. Well, what happens here? We have two possible states for the gas particles in this glass tube, right? On this side, we have one possible state for all of the glass particles in this glass tube. Going from two states to one state is less disorder than two states. We can kind of tell that. So we're decreasing in disorder. Delta S is the change in disorder. Decreasing, it means that we'll have a... Decreasing means that for question... What is this? Question 29. A, we will have a negative sign. Negative sign because it's decreasing. And then we look down here. We have silver chloride, solid silver chloride, and it turns into an aqueous solution of silver and chlorine ions. That's going from one state to two states, so that's more entropy. But it's also going from solid to aqueous. A solid has far fewer states than an aqueous ionic solution. It can be anywhere inside that solution. That's a whole ton of states that are possible versus a solid where everything's bound together in a crystalline structure. So B is a definite increase in entropy. Oh brother, it's a definite increase. It's a big increase going from a solid to an aqueous. It's more energy than a liquid even. Then we look here, two states going into one. Again, in C, two states are going into one, and there's actually three molecules in C that are going into two molecules in its product. So that's a loss of states, and they're gases. Gases have a functionally infinite volume that they can take up. It depends on the size of the container, the volume they take up. So versus a liquid which has a finite volume, a liquid won't get bigger to fill a bigger volume. Liquids can fill a volume, but unless only to a certain point. They cannot get larger like gases can. Gases can expand to fill any volume that they can get a whole bunch of states. So C, we know C is we're losing states and we're losing possible conformations. So C has to be negative. Now let's go to D. What is D? D is going from H2O is going from a liquid to a gas. Well, what did I just say about liquids and gases? Liquids have a finite volume, while gases have an infinite volume. Can have a functionally infinite volume in a functionally infinite number of positions inside of a container. So it's an increase in entropy. For the sign is positive, it's an increase in entropy. And for question 31, it asks us a very similar set of questions. It asks us at which substance has the greater value of S at this given temperature. Well, they give us graphite and diamond. Both of them are solids. But something important about graphite is not a crystalline solid. It's a layered amorphous solid. Well, it might not be it's probably not amorphous. It's a layered solid, which normally would be very low in entropy. And it is very low in entropy, but a diamond is a crystalline carbon solid. A crystalline solid is extremely low in entropy. Crystalline solids will normally be extremely low in entropy. So an important thing to remember is when you compare graphite to diamonds, a layered solid still has more possible entropy than a diamond, which has all of its particles in an ordered state. Almost all of its particles in an ordered state. Not all of them. If it was, it would be at absolute zero. But diamond has will have a much lower entropy. So for 31, graphite has the higher entropy value. For question B, this is question A. For question B, we got a liquid and a gas to compare. Well, what did I just say? Infinite volume is much more entropic, has much higher entropy than a fixed volume, even though they both can expand to fill containers. So, they both can fill a container, spread out and fill a container. So the gas will have higher entropy than the liquid. And so for B, the gas that is what gas is this? This is 2 carbon, so it's butanol, something like that. Not butanol, ethanol. This is ethanol. This is ethanol. Ethanol vapor is more entropic than gas. Ethanol vapor is higher entropy than the ethanol liquid. And this is solidified CO2. Solidified CO2 is dry ice, and it's a solid. Solids cannot expand to fill containers. They have much less positions, and they're more structured and more ordered than gases. Solids are below liquids in the entropy scale, so it goes from bottom to top: solid, liquid, gas. Gas being very highly favored by entropy. Most things. So we have CO2 gas. CO2 gas is much higher in entropy than the solid CO2. And that is all of the questions you had. Now, during the lesson, I got really flustered because I couldn't remember something. I'm sorry about that. Normally that doesn't happen. Normally I come in a little bit. I was pretty prepared this time, but sometimes you just draw a blank and you can't remember what you're trying to say. That happened to me this time. I apologize. I didn't want to make you sit through me trying to remember what I was doing, because it costs you money for me to sit there and think. Well, this time it didn't cost you money, but normally it costs you money for me to try and find myself from being lost. So I apologize for that. But that's all your questions for today. If you have any questions, don't feel free to write me a message. Have a nice day. Bye-bye.